Hey, everybody, and welcome to another episode of Adventures in Machine Learning. I'm your host, Charles Max Wood, and we're talking to Rishal. Now, you're in South Africa, which is a place I've always wanted to visit. I think it's the videos of the sharks jumping out of the water and eating the seals or whatever that I've seen from down there. But you're the author of Grokking. Let me see if I can get this right. Grokking Artificial Intelligence Algorithms for Manning, which makes you an expert, right? Because you literally wrote the book on it. But yeah, I'm super excited to talk and just kind of figure out what's in these algorithms, how to approach them, how to understand them, and things like that. And yeah, just welcome to the show.
Great. Thanks for having me, Chuck. One thing around expert, actually personally kind of really dislike that word.
Ninja. Do you prefer ninja?
I dislike all those words. The reason being is I think, it's just a personal thing. I think everyone, including myself, always has something to learn in whatever space you're working in. And when you say expert, people think you have every single answer to everything. Yeah, just an aside.
Yeah. It's funny how people approach that. For some people, it's you're an expert because you know a little bit more about a thing than somebody else, right? And then for others, it's this. Well, yeah, I can ask you a question. You just know off the top of your head, boom, right? Anyway, so yeah, in that case, maybe that's a case of human artificial intelligence. Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium. Anyway, let's dive in and talk algorithms here for a minute. So we've had a lot of conversations with people over the last few months that we've been doing this, where we've been discussing like specific use cases for artificial intelligence, or maybe we've talked in general about a particular algorithm or approach to solving a particular problem. What's the focus of your book, though? Because it seems like it's a little bit different from that.
Yeah. So it's quite interesting. I mean, I didn't actually with the idea to write this book. It happened from, I've been giving a few talks at some conferences, introducing neural networks to people. And it was mainly developers. And it came from, I guess, something I saw happening around me in my work and the community I'm kind of part of, where people felt quite afraid to experiment with these techniques or technologies because it was really math heavy, or a lot of the literature and material you'd find is really math heavy. So I think after doing a few of these, Manning approached me to, see if I'm interested in maybe writing a book with them. And this whole book is essentially a visual tutorial on various artificial intelligence algorithms, right? And AI, and that term artificial intelligence, I think everyone has a different definition for it. But basically,
Right.
This book contains not just kind of your typical machine learning and neural networks and reinforcement learning, but it starts at the beginning with kind of how do we solve problems in general. So it starts with introducing the intuition of thinking about data and thinking about algorithms and computing and problem solving. And then it kind of goes into search, which is something we've solved a long time ago, but still something very powerful in a lot of applications these days. And something that I'm really passionate about, which is nature-inspired algorithms. So, we've got genetic algorithms, which is based on the theory of evolution. There's ant colony optimization, which is based on how ants actually move around in their colonies, ask for help, collect food. And then there's also particle swarm optimization, which is based on how birds and bees and those kind of things actually flock. So essentially, in a nutshell, it's a kind of gentle introduction to these different algorithms where the teaching method is more focused on kind of visual learners, I would say, as well as, kind of practical examples that you can work through rather than, theoretical kind of math proofs that you would study.
Right. That makes sense. I kind of want to roll back to the initial approach that you had as far as just talking about how we solve problems and things like that, and how that kind of leads into some of these algorithms. So what does that look like? We're kind of laying out the fundamentals here. Where do you start with people?
Yeah, so I'd say chapter one is really focused around building the intuition about and the mental model about these different words that you might come across when learning about AI or machine learning or whatever the case might be. So, kind of creating the taxonomy and this model of how things fit together. That's basically what chapter one is centered around, and that's important to kind of understand the concepts further along in the book. And it's kind of written in a way where each chapter kind of has concepts that build on another chapter. So I might have mentioned that, it's not really math heavy. It's not to say that it doesn't contain any math. It does introduce the math to the reader. And you might find that something introduced in chapter two is useful in chapter three, and so on and so forth. So that's the kind of makeup of it.
Right. So how do you start thinking about different algorithms? Because it seems like different algorithms are kind of, so yeah, they're focused on specific types of problems or specific maybe solutions to a wide breadth of problems. So how do you start thinking about the different algorithms and whether or not you need to know them?
Yeah. So there's this concept of old AI and new AI. I'm not too sure if you're familiar with that, but old AI is essentially when humans, or programmers would actually figure out what the rules should be for a specific algorithm. Examples of this are things like expert systems, where you have really complex rules, a really complex rule set, and the rule set might even be a little bit dynamic, but you always understand what the inputs are going to be and what the possible outputs would be given some input, right? So things like search algorithms that are spoken about in the book are really useful there. And that's useful for when the problem is kind of well defined. So if you're trying to build a bot that plays chess, I know chess has been a buzzword these days with the Queen's Gambit being really popular on Netflix. So if we use that as an example, the rules of chess are well known. The problem that we're solving is looking into the future of all the possibilities of moves, right?
Right.
Whereas if we're looking at, say, Spotify recommendations, you're listening to different types of music. I don't know about you, but I have really diverse kind of taste in music, and I'm pretty sure that algorithm struggles a little bit, but it's still pretty good. So the inputs there and outputs are, I guess, kind of well defined, but how you get there is a lot more complex. Does this person like the tempo of the music? Do they like a specific artist? Do they like the genre? There's a lot more unknowns in that case. Whereas when you compare it with chess, the rules of the game are quite well understood. So I think, when you do have a fairly known problem space that you're working in, a classical algorithm like search might be useful. Whereas things like neural networks and reinforcement learning, have been really powerful when you have a lot of unstructured data, unknown kind of rule sets, and you kind of want to find patterns in that data to inform future decisions.
Right. So that makes sense. So then what algorithms are available for that kind of a thing where you're looking for those patterns and picking up the parts that you're going to use to make those recommendations?
Yeah, I mean, I guess there's so many options, right? And that's, I guess, part of the point of the book is to kind of inform the reader about what would be useful to use in what scenario. So yeah, I just pulled out at the back. There's a quick summary of it. I don't know if you can read that.
No, but
probably not.
If that's your book, people can go get it, and we'll have a link in the show notes.
Yeah. So basically, it's a bit of a guideline on what to use in what scenario. So, for example, I'm pretty sure you're familiar with linear regression. It's a very popular algorithm in machine learning. And this is really useful to find correlations in data. So do you want to see if a bigger diamond means that it will sell for more money, right?
Right.
That seems pretty obvious. But what if you take into account the quality of the diamond, the
Right.
clarity of it, the color of it, where it was sourced from? The same algorithm, but adapted to deal with multiple parameters would be useful in that case. So yeah, I would say it's kind of based on how well you know the problem space and if you have data available to train. If you don't have data
Right.
available, you should have rules to govern it. And yeah, the different approaches would be applicable in those different cases.
I gotcha. So yeah, you've got kind of a cheat sheet there as far as, here are the algorithms that you may want to use, under these specific circumstances or with this kind of data or things like that. How do you start to understand how they work? Because I've had it explained to me by some people that some of these algorithms feel a little bit like a black box, right? You put the data in, you know how it's set up, but you don't exactly know how it comes to the conclusions it comes to.
Yeah, so a lot of that is explained in these chapters, but one that I'm really passionate about, and maybe it'll be really interesting for you, is genetic algorithms. Don't know how much you
Mhm.
know about that, but
Not a lot, really.
if you think about the theory of evolution from Charles Darwin, basically what he says is every organism, it's about survival of the fittest. So
Hmm.
if you're um, a fish, for example, if you can get more food, you will survive longer, which means you will reproduce more, which
Right.
means your genes would be carried on further. And basically, that's a kind of running theory of how we even evolved. And generally, what happens is you have two parents. Okay, so you have one individual that might be really good.
Hmm.
Let's say this individual is really good at swimming, and another individual is really good at climbing. Theoretically, if you mix the two, you get a child that's good at swimming and climbing,
Right.
right? And that's essentially how genetic algorithms work. They randomly generate solutions given certain constraints. So, you might have a bit string that represents, in the book, it's a knapsack problem, but it could
Hmm.
be, a toy example could be the stock market. Do you buy, hold, or sell? And you have a
Right.
bit string saying B for buy, H for hold, S for sell. And you have a bit string for a certain time frame, and you say, cool, this is a solution. Let's apply that to Apple stock and see, if it's going to make us money. And you'll generate thousands of those solutions and you'll evaluate them with something called a fitness function. And in the case of that stock example I just gave, the fitness function would be, after replaying that sequence of buying, selling, or holding, how much money did you make? Obviously, the more money, the more fit that individual is.
Right.
And then what you do is you'll kind of choose one of those good parents and another parent. You'll mix them and you'll make a child. And that's generally done by kind of taking the first half of the one string and the second half of the
Hmm.
other string. And that's the general intuition of how genetic algorithms work. And the reason I wanted to mention that kind of metaphorical example is because that's basically how every chapter starts. It starts with this something you can relate to. So in this case, there's a story about moths. There's an actual proof of that where there was no population of black moths. There was a lot of white moths at a certain point in time, and
Right.
through industrialization, things became black because of smoke. Right,
Hmm.
in the Industrial
Yep.
Revolution. And the moths actually over generations adapted and they changed color to become black so that they're camouflaged with the environment of
Right.
buildings and things. And that's an example of how kind of that concept's introduced. But what I really like to do as well is create flowcharts of how the algorithm works. So rather than it being a black box, or I'm pretty sure for a lot of people, a lot of the time a mathematical formula can look like a black box. Just looking at a complex formula, a lot of the time you get kind of confused. I don't know what's happening. But what I like to use is flowcharts to show you what's happening at each stage. And there's also pseudocode. So
Hmm.
regardless of what kind of programmer you are, maybe whatever, JavaScript, Python, C Sharp, Java, it doesn't matter. you'd be able to kind of follow that flow chart and follow the pseudocode to actually implement the algorithms yourself.
Yep. Yeah, that makes sense. And I think that's really where things kind of broke down for me was just, I'd go copy an algorithm or go copy some library somewhere, right? And I'd pull it over into what I was working on and I'd get the result I wanted, but it was magic in between, right? And I like that idea of, just putting it into a flow chart and just walking through it. I mean, even on paper, right? And just kind of going, okay, I'm kind of getting the pieces here for what's going on. And I can see step by step how it's adapting, right? And so it's got some weighting in there and some other things that it's doing, but as it kind of moves through it, it's like, okay, this is selecting for this, that's selecting for that, and at the end of the day, you wind up getting the right answer basically, or you wind up getting a good answer in some cases, right? Like the recommendation engine, I don't know if there's a right answer, but there are better answers than others. And so, I'm getting a good answer. I'm getting an answer that I'm looking for. And at the end of the day, I can see in stages how it got there, right?
Yeah, yeah. And I'm a very, very visual person. I really like kind of representing things visually. And related to what you're talking about, for example, in the neural networks chapter, you actually see each node in the neural network, each, I guess, hypothetical neuron change value, right? And you'll see exactly what numbers kind of got inputted and manipulated to change the value of that neuron. Whereas typically when you're looking at a neural network, you give it some input, you give it an output, and the rest is magic. And what I try to do there is, kind of give the reader a window into what's happening with each and every element in that network. And let me be honest, most of the time when we're building solutions, in the real world, we very rarely need to go and understand those calculations, what's happening at that detailed level. But I think that by understanding it to a certain degree, you have a level of confidence and also ability to kind of debug and investigate and figure out what's happening in there if things do go wrong or if you don't get the results you need. And something that's becoming quite, I guess, popular or prominent as we move forward is the kind of, I guess, legal and ethical concerns around machine learning and AI.
Right.
Some, I guess, regulations or proposed regulations want companies to be able to tell the customer or some authority, what did that algorithm do? What did that calculation do to come up with a decision? You can't just say, well, it learned from data. They want you to be able to kind of reason about why it's making certain choices. Example of that is, I think there was a story about an organization that seemed to have unfair loan grants. It was granting some people loans and other people it wasn't, but they were in, the parameters were quite similar. They couldn't kind of explain why that was happening. And, that sparks concern. If you don't know why it's happening, how can you make the decision? And I think if, a lot of the time as developers or engineers or kind of people that are implementing tech, we often forget that we are in some shape or form also responsible, even partly for those outcomes. So the better we can prepare ourselves, the better we can understand what we're doing, the better we can make those decisions for whatever the outcome would be.
Hey folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there. The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
Yeah, that makes sense. I mean, for me, if it is or isn't a good, for the loan, for example, right? If it's going to be a loan that's going to be paid back on time, blah, blah, blah. I get that you want some kind of qualification. But yeah, the computer told me no isn't necessarily a good reason to give somebody. The other thing is that I think we all have this innate idea around fairness, like what's fair and what's not. And so we always wonder a little bit, oh, well, is it because I'm from this place, or because I look this way, or because I want to do something that's unconventional? And that's why it's telling me no, right? And so in those cases, it may not be fair, right? Because somebody else who has slightly different circumstances than me, that may or may not actually impact their ability to pay it back any better than I can, may actually get that loan. And that's what people worry about there too. And so by having it this opaque system, it's hard to know that it's fair. And that's what I think we see a lot of people kind of get hung up on. Where in reality, it probably is measuring 95% of the stuff it's measuring is legitimately plays into whether or not, historically other people have paid back their loans. And so it's this interesting balancing act, I think, just from the standpoint of, is this the right thing? Is it doing the right thing? And these algorithms don't have a sense of morality. They don't have a sense of fairness. They don't have a sense of whatever, right? They work off of, how you set them up and what you train them with.
Yeah, I agree with that 100%. I think, especially with kind of enterprise at the moment, there's a little bit of an obsession with automation,
Mm-hmm.
And we look at maybe some of the role models, the giants like Netflix and Spotify and Google and Facebook and all those companies. And, they automate a lot of things. And I think there's a place for automation, but I think, for the example you just mentioned, shouldn't that just come down to human judgment? Like, let the computer give you an output, okay? Maybe not as black and white as yes or no. Maybe give you an indication,
risky.
or yeah, and let a person go and look at the details, go and look at the application, go do what they need to do to make an informed decision. I mean, when you need a show recommended to you on Netflix, the consequence of the recommendation being bad is very low. Maybe you waste 15 minutes watching something that you didn't want to watch.
Right.
But there's much more severe consequences in other areas like finance or healthcare. And I think people got to be careful, especially decision makers in these organizations. Like, there is this obsession to automate things because we're going to streamline things, we're going to be more efficient, but that doesn't mean you're going to be more effective. You, like you said, you can't simulate morality in a machine.
Yep.
And I think beyond morality, it's, I think we're pretty amazing. As humans, we're able to put together these abstract concepts and string together these relationships. And we can't explain what's going on in our heads, but we can reason about it that way. Whereas, the computer is going to do what you ask the computer to do. And if it sees something new and it doesn't have data, let's say we're doing, deep learning or something, it sees something new, but it doesn't have historic data that can inform what that means, it's not going to know what to do. Whereas, generally we do.
Yep. So I really like your approach to kind of breaking down these algorithms and then thinking about how they come into play and, some of the ethics and morality around this stuff. But I want to kind of switch gears back to the algorithms themselves. So we've talked about evolutionary algorithms, right? Where it's, okay, we take, kind of half of this approach and half of this other approach, or half of this information, half of this other information, and kind of play it through the system and see how it works. And I'm pretty sure we've talked a lot about neural networks. That's something that it seems like a lot of people are working on right now. But you've got this swarm intelligence, you've got ants and particles, and you mentioned them at the beginning of the show, and they're in your book. So how do those work? Like, how are those different from the evolutionary or neural networks?
Cool, yeah. Let's talk about the ant colony optimization. And what's really cool about that one is it's almost identically mapped to how ants operate in the wild. So if you've ever seen a trail of ants walking in your kind of garden or on your patio or something like that, you might notice that they always keep this kind of single file trail that they're following, right? And why they do that is something called pheromones. So ants drop pheromones, and they have a variety of different pheromones. And pheromones are just, you can see it as perfumes. They each have a different kind of scent. And an ant will drop a pheromone, and another ant will pick up on that pheromone. So the reason you see this trail of ants, not to say that no ant walked anywhere else. The reason they keep on that trail is because the pheromone intensity is the strongest on that trail, right?
Right.
And what we found through studies on ants is that ants actually find the shortest path between a food source and their home or their colony. So, and they use this concept of pheromones. So imagine a few ants take two different routes to get to a food source and back. The ants on the shortest path actually end up leaving behind stronger pheromones. And obviously, the more ants on that trail, the more intense that trail of pheromones becomes, and that becomes the shortest path between the food source and the colony. Yeah. And essentially, the ant colony optimization algorithm is really great at solving shortest path problems. I'm pretty sure you might have heard of the traveling salesperson problem, where a salesperson has to travel to 100 different cities, but they have to minimize their kind of total distance traveled. This algorithm is perfect for solving those kind of problems. It's also been used to solve telecom network routing problems, believe it or not. And basically, the algorithm works in a way where you simulate these ants. You basically deploy ants starting at different or going to different locations, and then they move to another location based on an element of randomness and the pheromone intensity on that path. And the emergent behavior is that the shortest path between all of those different nodes will become apparent after a certain number of iterations of the ants moving around. So that's quite a fascinating algorithm that solves important problems in computer science and in real world application. But it's really cool that it's inspired almost directly from watching real life ants work.
Yep, that's fascinating. It kind of I have Google Maps in my head from that, right? But yeah. Are there other uses besides? I guess you talked about the network, right? And that matters because you can get data back faster, right? If you go the most direct route. Other places where this algorithm's used?
Yeah, I think it's generally most useful when you're trying to find the shortest path, whether that be, networks or other problems. Maybe you're a logistics company that needs to route your trucks, to optimize fuel, optimize deliveries. The algorithm can be useful there. It's also been used in strange ways for example, edge detection of images. You can manipulate an image based on the pixel intensity, the pheromones along the edges of a picture might get, I guess, highlighted. And people have used that algorithm to do edge detection in images. So I guess that's a bit of an outlier. There's much better ways to do edge detection, or let's say more efficient ways.
Makes sense. What's the particles algorithm?
Yeah, particle swarm optimization is based on, you could say, the flocking and behavior of birds or bees. So essentially, when you have a very large solution space, right? So imagine that, well, the example I use there is you've got a drone, you're trying to make a drone, and you're trying to find the correct ratio of plastic and aluminium, to use such that the drone can take off as quickly as possible, but it can also be resistant to the wind, right? That means it can't be too light, but it also can't be too heavy. So there's this kind of interesting balance in the materials that you're using. And obviously, in this very simple example, we're discounting, the aerodynamics of the design and such. So if you had that problem and you want to find this ratio, I guess the simplest way to do it is to brute force, right? You try every possible ratio between the two. But when that is a real number and you're dealing with, 0.1 plastic and 0.35 aluminium, right? Those levels, you're going to have to brute force that. And that's going to probably take a computer months or years, depending on the constraints you have, right? So what a particle swarm optimization algorithm does is it puts these different particles at different outputs, okay? So at different points in that solution space. So one particle might be at 0.1 and 0.5. So 0.1 plastic, 0.5 aluminium. Another one might be at 1.2 plastic and 2.5 aluminium, right? They get randomized in this space. And basically how it works is similar to how birds actually flock, is each particle tries to move itself to the center of the swarm. So if you imagine this 3D space with these particles everywhere, right? And it would be a 3D space with these two variables and whatever the output would be, that each particle tries to get to the center of the swarm, but it also determines if its fitness is better than the swarm's fitness, right? So every particle takes into consideration the result from the swarm. So if I have a friend all the way down there and he has a way better fitness to me, I'll move towards that particle. But at the same time, I want to move towards the center of the entire swarm. And just based on those principles, the emergent behavior is that after many iterations, you find that the swarm finds a global optima, right? I mean, it does have this risk of falling into a local optima. So if we talk a little bit about local optima and global optima, there might be a good solution at one part of the search space, but a much better solution elsewhere. And that's where you kind of tweak these parameters over, how much should I favor my own fitness? How much should I favor the fitness of the swarm? And, how much should I favor kind of trying to get to the center of the swarm? But yeah, that one's also quite a fascinating algorithm. It's used for optimization problems. So like if you're, I don't know, a factory that's trying to produce a new kind of biodegradable bottle, and you want to experiment with different materials, that algorithm would be really useful. The critical thing about that algorithm is you need, similar to the genetic algorithm, you need a good fitness function. So if you could simulate the chemistry of different kind of compounds, and there are programs that can do that, you can use something like a PSO to design the perfect kind of biodegradable bottle that will also last somebody, a decent amount of time, just as a hypothetical.
Right.
Yeah, that's actually how birds, when you see those patterns of bird flocks, that's actually how they work as well, in principle.
Interesting. That's really interesting. Well, I think we're kind of getting toward the end of our time. If people want to learn more, I guess they can go pick up your book from Manning, and we'll put a link in the show notes. I also have a link from Manning for, I think, 35% off, or a coupon, sorry. So we'll put that in the show notes as well. And then I think they actually sent me some codes I can give away. So if you go to devchat.tv/GrokML, then I will, or Grok AI, because it's AI in the title, Grok AI, you can actually enter your email address for the giveaway, and we'll give away 5 copies of the book. Rishal, are there other places that you like to send people, though, to kind of level up on this stuff?
Yeah, I'd say not necessarily places, but what I'd say is if you're interested in getting into, this kind of topic, I know it's hot and trending at the moment. There's a lot of kind of courses and degrees and all sorts of things out there. But if you feel like it's kind of out of reach or it's not for you, I'd urge you to take a shot. Like, doesn't have to be through my book. Just go try something simple. Go on to Kaggle. Kaggle has a lot of cool resources to get you kind of up to speed, at least with the basic concepts through some sample data sets. But I guess the core message here is, if you think you can't do it, maybe challenge yourself and try at least. Because something I've learned is that, when you let this kind of fictional story you make up in your head that something's way too difficult for you, then it's definitely not going to happen. But if you at least just try, you can make it happen.
Yep, absolutely.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams, or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
All right. Well, the last segment of the show is picks, and picks are things that we just shout out about on the show. So, for example, a lot of people will pick like books or TV shows. They'll pick a particular thing that they learned. Some generally is things that are making your life better, right? So I'll go ahead and throw out some picks just to kind of give you an idea of what we're talking about here. So the first pick I'm going to throw out is a book. It's a nonfiction book. Most of the books that I read anymore are, but this is one that I've been listening to on Audible. It's called The Hero with a Thousand Faces by Joseph Campbell. And it is a 70-year-old book. But what he does is he walks through basically kind of the epic journeys of the heroes in religious, mythological, and cultural iconology. And he kind of gives you the formula for creating those same kinds of stories. And what's funny is like the current state of the art sort of for movies and TV shows, they all follow this same story arc. And it's funny because I've started, like, even in a TV episode, I can almost pick out, okay, that guy's the culprit, right? If it's a mystery, right? That's the murderer. That and it's just kind of funny. This is the breakthrough that the protagonist is going to have. Just listening to this book, I've kind of picked up some of that, and it's been kind of funny because, yeah, a lot of these movies and TV shows are somewhat formulaic that way, right? You can kind of pick out the major elements. You may not be able to call like exactly how the hero is going to break through, but you can usually pick out they're going to break through in somewhat this way, involving this person or that person, blah, 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 right? So you kind of get the idea. And some of these movies too, like they try and turn it on their heads. One example is the Tenet movie that came out in September, I want to say. We went and saw it, right? And so they turned some of the tropes around, but at the end of the day, it still followed the formula. So anyway, fascinating book. So I'm going to pick that. And then the other thing I'm going to pick is I have a smoker. It looks like a mini fridge sitting out on my porch, but I have a smoker, and I love putting meat in it, and just, oh man, so good. I'm looking forward to smoking a couple of pork butts this weekend, and I freaking love the thing. So I'm going to pick a smoker. I'll put my particular model in or something that looks very much like it if I can't find the exact one on Amazon, because I think we got it at Walmart, but I'll put a link to it in the show notes as well, just so that if you're thinking, oh, well, that'd be nice. I think the one I got was $100 on a Black Friday deal, and they're usually like $200 or $300. So I'll see if I can find a similar deal for you folks and let you know where you get it. But yeah, I just, put a rub on the meat, throw it in there. And after, I think the ones that I have here, the pork butts that I'm going to be running through are like 8 pounds. So I have to run them for like 10 hours. And then, yeah, it's so good. Anyway, so that's my pick. Rishal, what are your picks?
Yes, while you're talking, your storytelling book reminds me of another book with a very different purpose. It's more towards kind of marketing and I guess communicating your brand or product or service. It's called building a story brand. And
Oh,
it's,
so good. Donald Miller.
yeah,
Yep.
it's actually exactly what you describe, but using those elements to, engage with an audience, engage with people. So I guess that would be one pick related to your one.
So good.
I think, other thing that's made my life better recently is I challenged myself to kind of do something in October. You might know Inktober. It's a art kind of challenge that gives you prompts every day to draw something around those prompts. So they might say hope, and you think of something to draw about hope. And what I did is I researched a different topic about the world, not necessarily tech related, but maybe CO2 emissions, maybe how's the fishing industry kind of evolved over time.
Mm-hmm.
And for 31 days, I basically just researched a completely different topic that I wouldn't normally go and learn about. And I kind of just wrote some doodle notes about it. So you can actually check it out on my website, rhurbans.com. But what I would say is, if you could learn something new every day, it's quite an ask, or maybe even just practice something new every day or something different every day. That's added a lot of value to me personally. So I don't know if that qualifies as a pick, but that would be one of mine as well.
Awesome. All right. Well, if people want to connect with you online, where do they find you?
Yeah, I think it's probably best place is my website, just rhurbans.com, or Twitter or LinkedIn. I'm pretty sure if you type my name in, you'll find me. I haven't found another person with my name and surname, so should be pretty easy.
Nice. All right. Well, let's go ahead and wrap this up. Thanks everyone for listening, and Max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.